Okay, I think we're live, and the numbers are steadily increasing. It's always a little bit of a slow start, people coming in. So may I ask if you can mute yourself? It's a bit distracting if we hear voices in the background. So, Dr. Poyna, I see there are 5 people in the waiting room, please. So a great big welcome to all our vector control community members in Asia Pacific and from many other parts of the world. There are people that are linking in from all over. These events where we can interact and share experience and knowledge, it's always a friendly and a pleasant experience. What a great group of people to interact with, and we thank you for your time. So I'm having problems here again with my screen. So on behalf of APMEN, I want to thank you all for setting aside time to be part of day 2 of our APMEN Vector Control Working Group annual conference. Just a reminder that this event is being recorded and we'll upload it onto our apmenorine.org website. Some people sometimes they miss some of the presentations, and then it's handy that they can go back to the recording and watch the recorded presentations. It's top quality presentations, so that's why people, it's a popular site for people to go back to and watch. So to officially open the event, we have the privilege of having sorry, I'm having problems with my screen. Of having Dr. Chantana Padungtod, who is Director of the Division of Vector-Borne Diseases, Department of Disease Control, Ministry of Public Health in Thailand. It's a pleasure to welcome you, Dr. Chantana, and we thank you for taking time from your busy schedule to give a short address to our National Malaria Control Program colleagues from across the Asia Pacific, as well as partner institutions and representatives from all over the world. So over to you, Dr. Chantana, and thank you again.
Thank you, Dr. Leo. The Honorable Executive Vice President of the Asia Pacific Leaders Malaria Alliance, Mrs. Amita Shebi, my respected fellow directors of National Malaria Control Programs and vector-borne disease control throughout Asia Pacific, distinguished guests, ladies and gentlemen. It is my great honor and pleasure to be here today presiding over the 2022 APMEN Vector Control Working Group annual meeting. May take this opportunity on behalf of the Ministry of Public Health Thailand to extend a very warm welcome to colleagues from the Asia Pacific region. It's always a pleasure to interact with like-minded professionals working towards the same goal of malaria elimination. I'm sure you will all benefit from the many presentations by vector specialists in the Asia Pacific region, sharing their findings and experiences and adding to our collective pool of knowledge. Great strides have been made in Asia Pacific in moving towards or sharing malaria elimination objectives. And I am very happy to say that in the Greater Mekong sub-region, we are very likely to have reached the goal of zero local transmission by 2027. But what then? Our mosquito-borne challenges will not be over, and we all continue to be challenged by diseases such as dengue, chikungunya, and others. So I like to propose that perhaps APMEN should broaden its scope of focus to embrace these other vector-borne diseases that surely will replace malaria as a major public health threat in years ahead. I am confident that this meeting will be an important step to strengthening collaboration and partnership among us. I believe that our good collaboration will bring about a private-public partnership in the future as well. Finally, I'd like to express my sincere gratitude to all organizations and their staff that helped to make this meeting a successful one. May I now declare the meeting open, and I wish you all a successful conference. Thank you very much.
So what a wonderful message. Thank you for those welcoming words, Dr. Chantana. Really warm, appropriate message you gave us there. Your message contains some sobering thoughts about the future of mosquito-borne disease in our region. And you said that while we will celebrate the elimination of malaria, hopefully in the not too distant future, we will have the other challenges to deal with, notably the arboviruses. So you made very appropriate comments there, and we will do well to listen to those sentiments of yours. Thank you for your thoughts, Dr. Chantana. We're grateful for that. Okay, this is day 2 of our annual conference. Day 1 was on Tuesday, and it was devoted to issues relating to vector surveillance and control, training shortfalls, capacity shortfalls, and a look at some of the courses that are available for NMCP staff to attend to try and address some of those shortfalls. Today, we will focus on the issue of outdoor biting. As you know, insecticide resistance is probably our single biggest threat in our efforts to control malaria. Definitely in Africa, that's for sure. But the other issue is outdoor biting, especially early evening when people are still outside of their bed nets. And also our lack of adequate tools to reduce this outdoor transmission. But we're fortunate to have several top experts in this field to give us some state-of-the-art insight as to what the current status is regarding some of the tools that are being developed to help in the fight against outdoor biting. On behalf of all of us, I'd like to thank these experts for their time to share their experience with us. After the presentations, we will have a Q&A session. So to our audience members, if you have questions, please put them in the chat box. There's no Q&A box, so just pop them in the chat box. Our staff will collect those questions, and then during the Q&A session, we'll get our panel of experts to respond to those questions. And then after the Q&A session, we will have a quick break. Sorry. So we'll have a breakout session, 2 groups, just to have it'll be a short breakout group session, and it'll probably take about 10 minutes, 10 maximum 15 minutes to fill in a questionnaire that relates to outdoor biting issues. And then we'll give some plenary feedback. So our first speaker is the respected Amir Galili, who's the Chief Executive Officer at the Western Company in Tel Aviv, Israel. And I believe Amir is the conceptual founder of the idea of attractive targeted sugar baits. He came up with this concept, and he developed this idea of attractive targeted sugar baits. And as you know, there's huge international interest in ATSBs, and we look forward to this update by Amir. Amir, over to you, please.
Okay. Hello, everybody. I will share my screen if it's okay.
Yeah, please, Amir.
Okay. I believe this is the one.
Take your time. Yeah, there we are. It's full screen.
Okay.
Well done.
Full screen.
It's good.
Excellent. Thank you very, very much. Okay. So ATSB is a short for attractive toxic sugar bait, or not toxic, targeted, we changed it. And this is basically said everything about what are we doing. And the first point, I would like to put things in the right place. The whole idea of going and kill mosquitoes through attraction of the sugar was by Professor Schlein and Dr. Muller, and based on their experiments, we developed the ATSB. The process of development was quite over 10 years, and I will try in maybe 20 seconds to summarize the 10 years. We defined the method, we search and define the attraction material, we selecting the active ingredient, design the application. You can see some of the applications, actually maybe more than 30 type of stations were developed and basically dismissed, mainly because they are too expensive and there were 3-dimension stations, which mean if we leave them, we are not going to have a place for people to live in the villages or wherever it is. We'll come to it later. And then we developed the production process and the production machines. We specified the deployment activities and the overall operation, and we established the QA procedure for all above. By doing this, we all the time try to keep the human safety, the environment, not to harm the environment, and of course, the social responsibility of this method, and not above, but extremely important is affordable price, because if we like to make it large scale usage, the price will be extremely important. Some of the introduction, we started in 2016 and 17 by large-scale proof of concept done in Mali, which demonstrated a significant impact of the mosquito, demonstrate a significant impact on the mosquito density. Following this POC in Mali, we received very generous and important, crucial support from the Bill and Melinda Gates Foundation, and shifted all our focus to vector control in sub-Saharan Africa by then. And our objective is to be ready for deployment following national and the PQ approval during 2025. Very short about the methodology. The ATSB method is attract and kill approach to eliminate mosquitoes. It's based on the need of mosquitoes for sugar. So we attract them with the volatiles. We give them sugar. The sugar do have an active ingredient inside and kill them. This is the very, very simple. And as you can understand, there are quite a lot of challenges during this process. This method, the ATSB method, is suitable for various species. We'll comment on it later, various applications, and of course, market segments can be used as well. The application. You can see at the middle the bait station. The bait station is two-dimensional bait station hanging on the wall. The bait station have two components. The bait formulation that include the attraction, the feeding stimulant, which is the sugar and the active ingredient, and the bait station that have to protect the bait. Just a moment, that have to protect the bait from the environment and to protect the environment from the bait. This is the purpose of the bait stations. At the same time, of course, it should enable the feeding of the mosquito on the bait, on the station. two main advantages. There are a few others, but the two most important advantages are we are speaking about outdoor vector control method, the first in class of outdoor vector control, which targeting mosquitoes that are biting outdoor. Also, because we are using gut toxin, we are speaking about different mode of action, and it's currently bypass the resistance mechanism that are current intervention methods. I would like just to divert a little bit and to present something that is not for the malaria, type of nuisance control bait stations. Very, I would say it's simple. You can see that just to put it and take it away, it's two-dimensional bait stations. It's not hang on the wall. It's very low on the grass in the yard. It's aimed mainly for Aedes mosquitoes, and it doesn't exist yet, but this is the direction for the, I would say, non-Anopheles, especially Aedes mosquitoes, our direction. Where are we now? During the last 3 years, we optimized the product design and developed the manufacturing technology. We currently can manufacture 3,500 stations per day in our site, and we already manufacture for more than 400,000 stations and ship to 3 African countries, Mali, Zambia, and Kenya, in order to evaluate it. The entomological trial supported by IVCC were completed with a promising feeding rate results. And I would like to mention that even I would say the very modest percentage of feeding rate, according to the models, can reduce the malaria significantly. Currently, the epidemiological trials are going on in Mali, Zambia, and Kenya, started approximately a year ago, and should last at least 1 more year. In the meanwhile, the PQ regulatory and policy process is on track, and we are waiting for the EPI trials results, which mean the public health value to confirm it in order to be able to large deploy it. Few question and answers that this method is mainly raised. The first, I would say, what are the risks for the honeybees? It's checked all over. We are confident that bees do not attract to the bait, to our bait. This is one thing. The other thing is that the bees cannot feed from the bait because the bait is behind the membrane. So the bees cannot feed on it. From all experiments that we've done, the bees do not harm, bees and other pollinators do not harm by this method. Also, everybody asks, what about pet and children? The amount of active ingredient is very, very small, and children have to feed, I don't know, tens of stations to eat in order to be harmed. This is one, just to make sure that also that they will not feed at all the children or the pet. We also added Bitrex that 1 bite can be taken, no more after that, because it's really, really bitter. The environmental effect of the station is a minimal. First, because we are not spreading any active ingredient to the environment. And secondly, we are speaking about extremely, extremely low quantity for each bait station, less than a gram, something like half a gram of active ingredient within a station like this one. What is the next step? In order to be ready to deploy, we plan and initiate an excessive access plan, which include to engage with NMCPs to map the program in Africa, to complete the regulatory, and to make sure, if necessary, to optimize the activity of deployment in order to reduce the cost. So the three main activities we plan with as part of the access plan, and of course to build the all required manufacturing capabilities that we need. Taking home message. We believe that ATSB is a game changer to fight against the malaria and other borne disease, mosquitoes, I would say. It's first-in-class vector control intervention for outdoor use, expected to address a gap between the current indoor intervention and the actual situation. Large operation in general then generating the ATSB public health value. The modeling, as I mentioned, suggested that even a modest daily feeding rate, killing the rate that substantially decreased the transmission of the malaria. The last comment that it's important to remember that this is the first-in-class, the first product. It's not in the market yet. And we are still learning about the challenges that it brings with it, as well as the potential of such new intervention. And I would like to thank for our partners, mainly for Bill and Melinda Gates Foundation, for the support, for IVCC that are with us during the last, I would say, 7 years, and the whole people that currently very much active in Africa, the CDC, the PAS, LSTM, and universities like Bamako University. Thank you very much for this.
Okay, Amir, what a wonderful, exciting presentation. You know, I can't help but feel excited and optimistic about this product that you've given birth to, and you're slowly nurturing to hopefully PQ, if all goes well, pre-qualification by WHO by 2025. It all sounds very promising. It targets that outdoor biting component. It ticks all the boxes of being safe to use. I have 1 or 2 questions. I am sure there are many questions from the audience, but I'm going to ask our audience members, put those questions in the chat box, or keep them in mind for the Q&A session, which will be at the end of the 5 or so presentations that we have lined up. So we're not going to have a Q&A session after each presentation. We're saving it up for a group session at the end. So Amir, wonderful, excellent presentation, very thought-provoking. Sounds very, very promising. Thank you for that. I have absolutely no doubt our audience enjoyed that presentation. Our next one is by Dr. Din Siafruddin, who is going to talk about the impact of a spatial repellent product on Anopheles and non-Anopheles mosquitoes in Sumba in Indonesia. So Dr. Siafruddin, thank you to you for making time, sharing your experiences with us. We look forward to your presentation. Over to you, Dr. Siafruddin.
Thank you very much, Mr. Moderator. It is a great pleasure for me to be sharing our more than 9 years experience actually in testing the spatial repellent product to see the impact on malaria first, and then possibility of being used as a mosquito in general. If I may ask Ms. Wulandari to show my presentation because I couldn't do in my computer. I'm actually now at the airport on my way back to Jakarta. Yeah, so that's why I asked. I send my presentation to Wulan, and
Okay.
hopefully it could be shown now.
Yeah, thank you,
Yes.
Wulan. Thank you, Dr. Syafruddin. Okay,
Yes.
please proceed.
Yeah, this is actually the one that I present. That I would like to present today is actually an integral part of our activity in Sumba to from the beginning proof of concept of the use of facial repellent to decrease malaria incidence. Slide, please. And the goal and objective is clear here. So to see, to evaluate the public health impact of spatial repellent, and particularly to see its impact on the epidemiology, particularly malaria here. Actually, a couple of years ago, it was started in 2 centers. Yeah, so one in Sumba, Indonesia, and the others to see the impact on dengue incidents in Peru. So I would like to further report what we have been collecting during this process or this randomized control trial. Slide, please. Yeah, this is the topic of my presentation today, impact of a spatial repellent product on Anopheles and non-Anopheles. Yeah. Slide, please. So as a part of the parent trial, initially we designed this trial in a double-blind randomized control trials involving 24 clusters. 24 clusters in really area in the island of Sumba, Indonesia. And then we have cohort of 54 in each cluster children aged 5 from 6 months to below 5, and then they are given of course spatial repellent, which is actually a plastic transflutrine embedded on a A4 size plastics, and then hang in the wall of the house. And then we will compare the malaria incidence rate in each cluster who actually receive blindly active ingredient or placebo materials into the house. Slide, please. And for the entomological analysis, because during the trial, the intervention, we proved that actually only that show mosquito diversity and mosquito availability So therefore, after we discuss with the team, we continue for mosquito observations only in 12 clusters. But we have made sure that all 12 clusters is divided into 6 receiving AI or active ingredient and 6 receiving placebo. And then we will, after that, we conduct a regular human landing catch to catch mosquito at the sunset. In Indonesia, usually sunset start at 6 p.m. and then until 6 a.m. in the next day. So all mosquito species collected during the human landing catch activity, which is conducted every 2 weeks or bi-weekly, then we will analyze for parity, for sporozoite carriers, for others, for Anopheles, but we also collect non-Anopheles species to see whether there is an impact on density or availability. Slide, please. This is the condition of the traditional Sumba houses. So as you can see here, the wall is really made by bamboo thatch, and mosquito, of course, freely enter the wall. So it is not quite clear whether this could be grouped as an indoor or outdoor, because mosquito can freely enter the house. But anyway, we install the either placebo or active ingredient materials containing transfrutin that actually designed for lasting in at least 2 weeks. So we have to then replenish or change the active ingredients in the plastics hang in the wall every 2 weeks. Slide, please. So then we will report, this is our results, which is focusing on the mosquito populations. So in the placebo and the active ingredient clusters. So we identify the mosquito by species, particularly for Anopheles, and then we count, we also determine the parity, and then we confirm by molecular ID, ITS2, or sometime with mitochondrial DNA to make sure that all species are correctly identified. And as you can see here, we can during the 2 years observation, so we can see that human landing catch mosquito actually decreased. There is a reduction in the Anopheles landing rate in general related to spatial repellent compared to placebo cluster. And although as we have reported before in the parent trial, although the impact on the mosquito population is really modest, only 16.4% and 12.1% outdoor. But if you conducted a sub analysis on that 12 clusters, we can see that the malaria incidence at that time really very promising, because close to 60% of malaria incidence reductions in the 12 clusters only. Slide, please. And this is the by species. So we can see which species that contribute to the SR, and different from African environment. In Sumba, the mosquito population, particularly Anopheles, really very diverse. Species diversity really very diverse all year long. So although sometimes the dominant change, like Anopheles sondaicus, change to other like Anopheles aconitis, but we can see that at least 10 species could every other week during the human vending catch. But slide, please. Yeah, but this is impact on Anopheles is actually not only promising, but we also see the effect of SR on the other non-Anopheles such Aedes and Culex population. So the picture is actually illustrated bi-weekly collection of Aedes and Culex population. And then we can, I'm sorry, we can see that the reduction in Aedes or Culex population is more pronounced compared to Anopheles. So we didn't at that time, because we focus on malaria, we didn't try to associate with the dengue incidents, but our colleague in Peru, which conducted at the same time for the effect of spatial repellent, found out that spatial repellent could apparently also reduce the density, the incidence of dengue. Slide, please. So this is the impact of the spatial repellent on human biting rates. We can see that not significant effect on the human biting rate. Slide, please. Also in the other, so on the parity.
Dr. Syafruddin, I think you've frozen.
Slide, please. Slide, please. Yeah. So I think as a conclusion, we can really say that the evidence demonstrating that Anopheles factor bite outdoor and indoor equally, and this is the effect of SR really promising to reduce the Anopheles mosquito landing rate. Yeah, not only Anopheles, but both Aedes and Culex also be impacted. And the documented impact on, on SR intervention on Aedes, Armigerus and Culex species point out to the importance that this spatial repellent could also be used not only for other vector-borne diseases. Big issue in Indonesia, particularly in eastern part of Indonesia, where malaria still very high incidence. Study the impact of the spatial repellent other mosquito-borne diseases is really recommended. So our group is now trying this spatial Africa and some other part, might be Sri Lanka if I'm not mistaken, for the effect on both malaria and dengue. I think that's all that I can present to you all, and we are ready for discussing the outcome. Thank you very much.
So from our side, thank you to you, Dr. Syafruddin. Good presentation, very encouraging results there. I found that despite only a relatively small reduction in biting rate, it seems to translate into a significant reduction in malaria incidence. That's very interesting, and for Anopheles, that is. And then a significant reduction in biting rate for Aedes. So it's very encouraging.
Yes.
So I'm going to ask that we save the questions, and there are quite a number of questions coming up. We save them for the question and answer session. If our presenters feel up to it, if you know, if you can double task, keep your eye on the chat box, and maybe you can respond to some of the questions in the chat box by typing in responses to some of those questions. Up to you. It'll save us a bit of time during the Q&A session. But Dr. Thank you so much. Very, very interesting and helpful presentation. Thank you.
You are welcome.
Thank you. So our next, what a fascinating lineup of presentations we have. The next one is going to be on targeted outdoor residual spraying by Dr. Victor Chomeov. And Victor, if I could hand over to you, if you don't mind. Thank you for that.
Hi. Can you hear me clearly?
Very clearly. Thank you, Victor. Shock glue unit Mesot, I think, Victor. Thank you.
Yes, thank you, Dr. Leo, for the introduction and the invitation. I have shared my screen. Can you see my screen?
See it very clearly. Thank you, Victor.
Okay, I will try to switch in full screen mode. Okay, so today I will present some results of our work on the evaluation of outdoor residual spraying for malaria vector control in Kayin State in Myanmar. I would like to introduce this talk by a figure taken from a study that we did in 2013 and 14, where we collected very detailed information on the malaria vectors in 4 villages for 2 years. And we analyzed over 40,000 mosquitoes in PCR to detect Plasmodium infections. And this figure shows a repartition of the infected mosquitoes according to the time and to the location, either indoor or outdoor. The time of the collection in this study went from 6 p.m. to 6 a.m. And each mosquito species or group of species is showed by a different color and shape. What we found in this study is that only 36% of the Plasmodium infected mosquitoes were collected indoors between 9 p.m. and 5 a.m. And it clearly shows that the outdoor and early biting behaviors of the relevant species of Anopheles mosquitoes challenge the efficacy of mosquito bed nets in this area. And this is why it is misleading to speak about residual transmission in this region, because by deploying mosquito bed nets, it covers actually only a marginal proportion of malaria infection. And this figure confirms previous work on an existing body of literature on mosquito bed nets in Southeast Asia, either epidemiological studies and other entomological studies. This is why we proposed outdoor residual spraying for malaria vector control in this region. And by outdoor residual spraying, we refer to the spraying of insecticide mists of residual mists on the outdoor vegetation located inside and around the village. So the first thing we did when we started to work on this problematic was to assess the longevity of the insecticidal effects of pyrethroid mist applied to outdoor vegetation. So we sprayed bushes in natural setting, and then we collected leaves at weekly interval for a rather long follow-up. And we performed standard cone test with a laboratory adapted colony of Anopheles dirus, fully susceptible to pyrethroid insecticides. In this series of experiments, we tested 3 different formulations of insecticides: a wettable powder of deltametrine, a wettable powder of bifenthrin, and a capsule suspension of lambda-cyhalothrin, which formulation was specially engineered to last longer on outdoor vegetation. We also replicated the experiment with the lambda-cyhalothrin formulation during the rainy season. And even if there are some limitations to this work, it clearly shows that we can obtain long-lasting residual effects on outdoor vegetation. Then we designed a cluster randomized trial in 12 villages in order to assess this intervention at scale on the entomological indices and on malaria incidence. So we are working, as Dr. Leo said, in Mesot on the Thai-Myanmar border. And we are running a malaria elimination program in Kayin State in Myanmar. And we selected a subset of this village to be enrolled in this study. And they were randomized to the intervention or control group based on baseline entomological data. And we used as a primary endpoint the biting rate of malaria mosquitoes, and as secondary endpoints, the parity rate, the incidence of vivax malaria, and the proportion of insecticide-resistant phenotypes as assessed with a standard susceptibility assay. We didn't look at falciparum malaria in this study because it had been eliminated from the study village before the trial began. So there were no cases on infected mosquitoes. I'm not going to go through the number into details, but this table summarizes the characteristics of the entomological indices at baseline. And it shows that we are in a typical setting of this area where mosquitoes are strongly exophagic, as shown by the ratio of the outdoor to indoor human biting rate. They are strongly zoophagic, as shown by the ratio of the cow over the indoor human biting rate. Mosquito bite very early and outdoor. Also another important observation is that in this area, the biting rates are quite high, but the infection rate with plasmodiums are very low. So it is very difficult to use entomological inoculation rate as an endpoint because the numbers of infected vectors are too small and it requires a much bigger sample size. In this area as well, the proportion of lambda-cyhalothrin resistant phenotypes at baseline was already between 20 to 30%. So it was quite relatively high. This figure shows the impact of ORS on vector biting rates. On the top panels represent the control villages. The bottom panels represent the treated villages, with the vertical dash bar showing the timing of the intervention. The left panel shows the indoor biting rate, the middle panel the outdoor biting rate, and the right panel the co-biting rates. So the scale are different because the abundance of mosquito is much greater on animal baited trap than by human landed catch, and there is more vectors outdoors than indoors. So using model output, we could estimate that the intervention decreased by 70 to 80% the vector biting rates for the 6 months after the interventions. And very interestingly, the effect was similar indoors, outdoors, and in the co-baited trap. And this is a key result of this study because it shows that by doing an intervention on outdoor, we can also impact on the indoor biting rates. So it means that even if sometime malaria vectors enter indoors to complete part of their life cycle, actually they spend most of their time outdoors. Now, if we look at the secondary outcome, the top panel shows the data on the parity rate, middle panel on Vivax malaria incidence, and lower panel on the insecticide resistance. We could demonstrate that ORS also reduce the parity rate or the longevity of the vectors between months 1 to months 3, and then it came back to baseline level, to similar level in both the control and sprayed villages. And when we looked at the incidence of Vivax malaria, we could show that the incidence decreased more in the treated village and more rapidly in the treated village than in the control. And when we look at the proportion of resistant phenotypes, we could also show that outdoor residual spraying was associated with an increase in the frequency of resistant phenotypes in the sprayed villages, but not in the control. As a discussion on the impact of ORS on malaria transmission, there are several mechanisms to take into account. There may be a mass killing of mosquito during the spraying when the mist contact with resting mosquitoes. There may be also a component on deterrence because pyrethroid insecticides have irritorepellent properties that deter mosquito from the sprayed area. And repeated exposures to sublethal doses of insecticides may also contribute to the effect. Importantly, this intervention has an impact on both male and female mosquitoes. And altogether, this results in a decrease in the abundance of mosquitoes, in the man beating rate, and in their longevity. Ultimately, this decreases the vectorial capacity and the entomological inoculation rate, and subsequently malaria incidence. About the impact of ORS on vector resistances, it's an important limitation of this intervention, but it's also important to look at this to make the parallel with the experience of indoor residual spraying on insecticide-treated bed nets in Africa, because similar observations were made after deployment of IRS and mosquito bed nets. The dynamic of emergence, spread, and expression of the resistances is not very well known. And the relationship as well between resistance, the efficacy of vector control, and the effect of transmission is also complex and not well understood. In this study, we didn't assess the mechanisms of resistance or the intensity. We just looked at the frequency of resistant phenotypes. It's a limitation of the study. It's also a recommendation for future research. In conclusion, ORS can rapidly interrupt transmission of malaria by outdoor and early beating malaria mosquitoes in an area where pyrethroid resistance is documented. There are several drawbacks to ORS, which limit its scale-up, especially its toxicity to the environment, because it's we spray high doses of insecticides and it's not selective, so it's an important limitation. It's increased vector resistances. We discussed about this before. There are logistic constraints and acceptability issues also with this intervention. So this must be taken into account to consider the scope of this intervention. Also, this is why we recommend that ORS should be used in combination with other interventions where a rapid intervention of transmission is needed, but not as a routine control, vector control measure to be deployed everywhere, every time. I'm thinking more especially here, for example, during malaria outbreaks in our setting, we had sometimes some events where local malaria transmission was re-established from imported cases after elimination. In this case, in a limited number of foci, it can be very useful to quickly stop the transmission. Finally, this study provides rare and important insights on the impact of vector control on vivax malaria. In the case of vivax malaria, the relapses confound the relationship between entomological inoculation rate and incidence. So it is an important piece of information that we report in this study, and we show that prevention of new infections should not be overlooked in elimination strategies. I put here the references to the work we published on this topic. And finally, I would like to thank you for listening to this presentation. Thanks to the study participants and to all the people involved in this study. Thank you very much.
Victor, thank you so much. Excellent presentation and important findings. Very thought-provoking presentation then, as you point out. You know, it's one of a portfolio of tools that we should be considering for deployment as a combination or package of interventions. And it has certain drawbacks: environmental contamination, potential risk to you know, important pollinating on, but you're upfront about that. So you're not trying to obscure those risks, etc. But it is one more tool in the toolbox that can be considered for application in certain specific situations. Well presented, good data. Thank you very much, Victor. Very, very interesting. Thank you for that, Victor. We're going to move to a subject that's close to my own heart, a personal interest of mine, the use of insecticides, and it's going to be an expert in the field. Many of us are well familiar with Dr. Kevin Kobylinski, who's been doing a lot of work on the use of insecticides, both in humans and in cattle and other domestic animals as well. So Kevin, it's a pleasure to have you as part of this group of presentations. Thank you for your time. I'm not sure whether you're in Thailand or in Indonesia, Sumba Island, but please go right ahead to your presentation.
Yes, thank you, Leo. Can everyone see my presentation?
Absolutely, yeah, full screen, all
Okay.
good, thank you.
Thank you. So I'll be talking about endecticides for malaria control, as Leo introduced. And so an endecticide is a compound that has activity against both internal and external parasites. There are several endecticides that are lethal to Anopheles mosquitoes. Ivermectin, apremectin, pipernyl are good examples of these. And so the concept is that the host would ingest or have the drug injected into them, and then toxic to blood-feeding Anopheles vectors. And this portrait very beautifully shows that. You can see that the person has swallowed a tablet, and now the mosquitoes that have fed on them are dying. You could extend that to from humans also to livestock. So there are many different compounds that you could give to cattle or pigs, buffalo, etc., that could be lethal to mosquitoes. And so a systemic endecticide is ideal because it targets Anopheles at the point of feeding. And so it doesn't matter where the host is in terms of physical location, indoors or outdoors, in the forest, in the field, in the village, or time of day or night. As long as their blood has lethal levels of the endecticide, it will kill the mosquitoes. So I'll be talking about ivermectin, as the other endecticides have really only had minor work done in laboratory settings or some small scale work in animals. So ivermectin is a macrocyclic lactone that refers to this internal ring structure, and it's isolated from the bacteria Streptomyces avermitilis. It's a very safe drug. More than 400 million people receive ivermectin in mass drug administrations every year. 300 million of those are in Africa, and that is given for onchocerciasis and lymphatic filariasis. And recently, Merck expanded their donation platform to 100 million people outside of Africa to accelerate lymphatic filariasis elimination efforts. Billions of livestock are treated annually. I actually haven't even seen a final number, but there's 50 times more ivermectin produced for livestock use than human use. So you can kind of see the scale there. As I said, it's lethal to Anopheles malaria vectors, which is why we're interested in it. And it represents a completely different class of insecticides than those used on insecticide-treated nets or an indoor residual spraying. It has a novel delivery route from either of those two methods, and it has a different mode of action, which is useful for mitigating insecticide resistance development. Here is a protein crystallography model of the glutamate chloride ion channel structure. And ivermectin binds at the subunit interface in the lipid bilayer. And when this occurs, it stretches the channel open. And so once the channel is open, that allows the chloride to continuously flow through the channel, which leads to polarization of the cell and paralysis of the nematode or arthropod musculature, and possibly death of the organism. So quite a few Anopheles have been investigated from around the world. Several of the important vectors in Africa, in the Americas, South Pacific, Asia. And I note here, a lot of people are interested in the recent expansion of Anopheles stevensii from Asia into Africa. And it does appear that stevensii is readily susceptible to ivermectin. So this could be a possible control measure for that vector. And a fair amount of work has been done in the greater Mekong subregion vectors as well. So basically, ivermectin. So that's a really good thing. I'll talk a bit about the historical work that I've been part of. And so for Anopheles gambiae, the primary malaria vector in Africa, we've shown in the lab that ivermectin compound is lethal to the vector. And so this would reduce the daily probability of adult mosquito survivorship. And then we've also shown this in mass drug administration settings in West Africa. So we've shown both in the lab and in the wild that ivermectin MDA can reduce Anopheles gambiae survival. And this should lead to a reduction in vector density. It can also delay the time to refeeding. So in this case, the black line, the vector had a blood meal without ivermectin, and the red line is vectors that had a sublethal concentration of ivermectin. And we can see here that the time to refeed plotted out here, and it's significantly reduced. So this is the second most important variable in the vectorial capacity equation. And then we've also looked at the ability of ivermectin to inhibit the development of the malaria parasite. So this is work done with falciparum in Anopheles gambiae, but we've also shown very similar results with Vivax in Anopheles aquasalis, Darlingi, Dirus. So it appears to not be vector or Plasmodium species specific. So this would affect vector competence. And then we also looked at the rate of development from day 12 to day 14, and we actually don't see any difference in this. So the only variable that we don't think ivermectin can impact in vectorial capacity equation is the extrinsic incubation period. And finally, some work done in West Africa shows that there is about an 80% reduction in the sporozoite rate after a mass drug administration. So this should, in theory, reduce the transmission to humans. And some follow-on work done in Burkina Faso by Brian Foy has shown, there were 8 treatment groups, 8 clusters. 4 were control and 4 were treated with ivermectin. And the ivermectin villages were treated 6 times, 3 weeks apart. And what we found, or what they found, was almost a 2-fold increase in the number of children that had no malaria episodes throughout the malaria season. And this is in a very intense area of transmission. So some of these poor kids had 7 clinical falciparum episodes in 1 malaria season. There is also a delay to time to first infection. And some modeling work has shown that if you combine ivermectin mass drug administration in the eligible population, which is basically everyone above 5 years of age, and combine that with seasonal malaria chemoprevention, which is done throughout the Sahel region of Africa, where they give anti-malarial drugs to prevent. And you're working with the same delivery team to treat the small children as to provide ivermectin with everyone else. And that's the subject of an ongoing trial in Burkina Faso. So coming back to Southeast Asia, we wanted to know how effective a single dose of ivermectin was at killing important vectors in the GMS. So people were treated with 400 micrograms per kilogram of ivermectin. And the bottom calendar here shows the timeline for subject interaction. Time point 0 with the star is when the drug was given. And just before a drug was administered, we took a blood sample and fed it to Anopheles dirus, observed their mortality or survival for 10 days. And we see about 95% of the vectors survived to day 10. So our control mosquitoes were happy and healthy. And then after we gave the ivermectin, 4 hours later is when you reach the peak concentration in humans. We see that it kills every last mosquito by day 3. And similarly with blood collected 24 hours later, we kill almost 100% of the mosquitoes. And then at day 2 and 3 after treatment, we still kill more than 80% of the Anopheles dirus. And there's still a pretty strong effect even out 6 days post-treatment, and a slight effect out at day 10 post-treatment. And when we compare this to minimus, we see that minimus is far more sensitive to ivermectin, killing every vector that fed on blood after 6 days of treatment, and then only a few survived when blood was collected at day 10 post-treatment. So the lethal concentration that kills 50% of the vectors for dirus is around 3 nanograms per milliliter, and minimus, which is much more sensitive, is around 0.4 nanograms per milliliter. And so these 2 vectors appear to bracket pretty well the most tolerant, ivermectin tolerant, which would be Anopheles dirus, and one of the most ivermectin susceptible, which would be Anopheles minimus. And the next slide will show the survival results of these mosquitoes to day 10. And here we've taken that same data and plotted against ivermectin concentration and calculated the LC95 So roughly, when we'd expect about 100% of the vectors to be killed is around 9 nanograms per milliliter. And then I plot the LC95 here against the ivermectin pharmacokinetic curve in humans. So this is after a single oral dose. We can see that after about 1 day, we've reached the LC95 threshold. When we administer to cattle, it's a completely different route. We're injecting it subcutaneously. And so there's a much slower release of ivermectin into the host bloodstream. And that creates a much more stable ivermectin plasma concentration that should be killing Anopheles diarrhea up until about 10 days after injection. And what's really exciting is some newer long-lasting formulations that are used frequently in South America, but not really used in Southeast Asia. So what they've done is altered the propylene glycol to glycerol ratio. And so this creates a slower release from the injection site. And they also triple the amount of ivermectin given. And so you can see here comparing to the standard ivermectin, which is the blue line, these other 3 formulations, with the red line being the most superior. And then when we plot that against the LC95, we see that some of these long-lasting ivermectins should be killing Anopheles 20, 30, and 45 days post-treatment. But actually, none of these long-lasting ivermectin formulations have been evaluated against Anopheles yet. And then I highlight this region down here. This is kind of the danger zone for ivermectin, because this is when we're reaching sublethal concentrations where mosquitoes might imbibe ivermectin, but they might not be killed. And so that could potentially drive resistance. And then with cattle, they defecate quite a bit more into the environment. And so this is potentially exposing your vectors that are in that same environment and little puddles where cattle are congregating. So that could also drive resistance as well. So we have a project that's going on now in Indonesia. It's called the Sumba Livestock Ivermectin Malaria Control Project. And this area has a lot of cattle and buffalo, not many pigs now because of the African swine fever has really reduced pig populations throughout a lot of Indonesia. What's exciting about Sumba is that there are plenty of Anopheles species and in very high abundance as well. And what's exciting for ivermectin is that none of these 10 species have actually been evaluated for ivermectin susceptibility. So this provides a great opportunity to look at a wide array of vectors at one time. So we'll work in 4 different study areas to maximize our Anopheles collections. And each study site will have 6 animals. There'll be 3 cattle and 3 buffalo. And 2 of those animals will serve as control, the top 2. And then the next 2 will receive the Ivomec Classic, which is the standard ivermectin without any other drugs, which is actually quite hard to find now in Southeast Asia. They like to add chlorcelon with Ivomec. And then the last 2 will receive the long-lasting Ivergen Platinum, which is the red line that I showed you on the previous slide. So we will expose cattle and buffalo in animal-baited net traps and then collect the blood-fed Anopheles. At the same time, we will collect a venous blood sample from the cattle or buffalo and save that detection later. We'll take the blood-fed Anopheles back to our insectary, and there we'll observe the mortality of the mosquitoes daily for 10 days, and then identify the mosquitoes to species. So there have actually been quite a few studies that have done similar work with treating cattle or other hosts, but none of those studies have linked this with the ivermectin blood level concentrations. And so that's what we're really excited to do in this study, because this will be the first time to assess ivermectin pharmacokinetics in Southeast Asian cattle or buffalo. So very useful for entomologists hoping to learn more about this vector control intervention and even just the veterinary community in general. And it'll be the first time to assess long-lasting ivermectin pharmacokinetics in Southeast Asia, and the first time to assess mosquito lethal effect of the long-lasting Ivergen platinum formulation. There are several other large-scale ivermectin malaria control field trials going on, and a few of those have just finished in the last year. So we should be seeing a lot more results coming out on ivermectin, both with the strategy of giving it to humans, but then also giving it to cattle, or in some cases, combinations of ivermectin to humans and cattle, and then also various combinations of ivermectin with anti-malarial drugs. And so I post the funders here just to show that there's a lot of interest from many different funding agencies in this concept. And then finally, I'd like to present some of the benefits and drawbacks to treatment of humans or livestock for malaria control. In humans, we directly target the human feeding anopheles, which is our main goal. And we can target the exophagic and corpuscular vectors, which several other control measures can fall short of. There is a clear direct personal benefit to giving ivermectin to people in terms of treating their neglected tropical diseases. If people reside in an area where they're more likely to get malaria, they're probably more likely to have other NTDs that ivermectin can help control. And we have field evidence indicating a clear effect on vector populations and reduction in clinical incidence. Also exciting, there have been two manufacturers that have recently been WHO pre-qualified. And so this is important for any vector control intervention having WHO pre-qualification. So that way large donors can purchase the ivermectin from these companies. When using ivermectin in livestock, we target a wide array of anomalies. And then we also target the exophagic and corpuscular vectors. There should be very noticeable increase in livestock weight gains and milk yields that the livestock owner should recognize, and hopefully that will help maintain high compliance with the control measure and satisfies the concept of One Health. There are long-lasting formulations with which much longer drug half-life compared to the human formulation. So we have a longer duration of efficacy when using livestock. And then it's also far, far easier to get novel formulations and compounds to get approval for use in livestock than it is in humans. And there are other effective insecticides approved for use in livestock in case you wanted to do some type of rotation, like we do with indoor residual spraying, or maybe there are situations where these other drugs may be more appropriate than ivermectin. One of the drawbacks is that we need to identify the manufacturer and establish the cost of this, and that has not really been finalized. It likely requires monthly administration, so we would need a lot of community engagement in order to encourage the people to maintain interest and compliance with MDAs. There could be potential resistance development due to adult anopheles exposure. And there are currently no other mosquito lethal insecticides that are approved for human use. Drawbacks in livestock is that we're lacking any field trial proof of concept evidence. Does not guarantee effect against human feeding anopheles. So you're targeting any anopheles that feed on livestock, but those aren't necessarily the ones that are transmitting malaria. Like for humans, we still need to identify the manufacturer and what that cost would look like at scale. It likely requires multiple administrations. There could be potential resistance development due to both adult and larvae exposure, especially due to the long drug half-life at mosquito lethal concentrations. And my biggest concern is that we may select for vectors that feed more frequently on humans if we remove all of the mosquitoes that feed on livestock. So this needs to be monitored to see if there's shifts in behavior, and we really need to make sure we know what species we're trying to target, what are critical in the area. So with that, my main recommendation is to not look at these as competing either or methods, but it's probably most logical to treat both human and livestock at the same time to maximize your vector exposure to ivermectin. And that's all for my presentation. Thank you very much for listening.
Yeah, great presentation. Thank you so much, Kevin. I quietly applaud, clap hands here. Really great presentation. I can't help but like this particular approach in Asia, because in such large areas of Asia, cattle are kept by most households, probably in rural areas, in close association with households. It's often even inside households at night, where they keep the cattle inside the home at night. So perfect opportunity for application of at least cattle administered insecticides, plus the benefits of reducing the worm load, anthelmintic effect, increasing the meat and milk yield, but there are drawbacks, as you pointed out as well. So but a big addition to the potential toolkit available for application against outdoor biting, but also for mopping up persistent pernicious residual malaria areas, where one could apply this method to good effect, I think, to mop up residual malaria. So thank you for that, Kevin. Lots of questions coming in. Presenters are encouraged to go into the chat box and maybe respond to some of those questions. But we have one more presentation. It's not strictly about outdoor biting. This is by Dr. Pongsakon Sadakon, who was going to give this presentation on day 3, but for specific reasons asked if he could give that presentation today, and we're very glad to accommodate that request. So Dr. Pongsakon is going to talk about the malaria situation and vector-borne disease control challenges in Thailand. Dr. Pongsakon, thank you so much for your presentation. We look forward to what you're going to share with us. Please go ahead.
Hello, everyone. Do you hear me clearly?
Very clearly, thank you.
I'm from Division of Vector-borne Disease from Department of Disease Control. So today I'm gonna talk about the Thailand malaria status and vector control challenges in Thailand also, absolutely. So okay, this is my outline. So I will talk about the situation of malaria in Thailand, and also national malaria elimination and vector control strategy, and talk about primary vectors, and also the status of insecticide resistance from malaria vectors, and also the key correlation of the LLIN and also IRS, and entomological monitoring, and also the major challenge and the way forward for 2022. This is my outline. So this slide shows the current case, the malaria situation in Thailand. So you will see that in this year we have more than 187% increase from last year. The majority of cases occur in the Thai-Myanmar border. So so 25 of cases are non-Thai, and also we around 95% falciparum vivax, and this is like the situation in malaria. So we have a 20% vermeil, and also our indigenous case increased by 53%. Okay. Yeah, the Thailand, this is the national malaria elimination strategy by 2017 to 2026. So we set target about 2024. Thailand is free from malaria, and also by 2023 the PF will eliminating. So this is like the strategy by improve like many intervention, also prevention of pre-infection or POR. So like we monitor and evaluation, we accelerate malaria elimination, and also we do a lot about developing appropriate innovative measure and model. So this is like the mechanism we put in the national malaria elimination strategy, Thailand. By the way, in Thailand, we had a strategy from for case notification, investigation, and response. We call 137 strategy. For 1 day, by receiving after the malaria confirmed, we will notify the area or the responsible people to do within 1 day, and also within 3 days, the case will navigating by the epidemiologist or interpreted in the area. And if after that, within 7 days, we will separate in the active A1, restrictive B1, and also the non-restrictive B1. In each area, they have like a measurement in each area. So, for example, if the active A1 or in the A1 area, we will confirm indigenous and also import case. We will like a activity like, for example, like a reactive case detection. Also, we do vector control and BCC. And for B1, we do, if we confirm that there are import case, we will do like also BCC and also reactive case detection. And if they are indigenous, we also do for-file investigation, which include the entomological survey and also mass spot screening. And we add another like a vector control measurement like a ITN or IS if they confirm that it's the transmission area. So this is like our strategy to dealing with malaria. And for vector control strategy by area stratification, in this when we do vector control, we have a measure in different depending on area stratification. So in the main focus on the vector control, we also, if the area is A1 and or A2, we will do like a regular IRS indoor resource space, and B1 we will not do from the areas, this area. So but however, in supplement list or special IRS, we will do A1 and A2 and also B1 as well. Also like for impacted mosquito net, we will spread for only A1 and A2 area. You will see that we have a fogging, but if fogging is only A1, A2, but in case if there are the outbreak, we also do in B1 area as well. So we will have biological control only A1 and O2, and also in case of outbreak, we decided to do that in B1. For environmental control, we do as well as A1 and A2. Reduce humans exposure to malaria vector by support the repellent, we do in A1, A2, and also in outbreak we do in B2 area. This is like the summarize of vector control strategy by dividing by area stratification. For primary vector in Thailand, we have three main primary vector. First is Anopheles dilas, and second is Anopheles minimus, and the last one is Anopheles maculatus. This is like a primary vector in Thailand. We also found this in area in the malaria area. The map in the picture, you see the different map. The first map is the A area. So we have the distribution of malaria vector in Thailand. You will see the different color means the different species. The red is dilac group, and the green is maculatus group, and also the yellow is minimus. So you will see in the A area, we almost found like a minimus in the Thai Myanmar border, and also we found some dilac group in the east of Thailand, and also the Cambodian Thailand border, and also we found the maculatus group and minimus in the southern part of Thailand near the Thailand-Malaysia border. For the B1, this is like we survey, we found the dilacs in the southern part of Thailand and some in the east part of Thailand. So normally in Thailand, both of A and B1, we found the minimus as the primary vector in Thailand. So for susceptibility tests in Thailand, we do susceptibilities as you see in the table. There we show the two main chemical insecticide with insecticide group. The first one is organophosphates. We do phenylthion and malathion. You see the discrimination concentration and also the export period for the unit is hour. So for pyrenol, we do alpha cypermethrin, cyputrin, deltametrin, bipentine, and permethrin. This is followed by the usual guideline. So this map shows the status of insecticide resistance for malaria vector. You will see that in different insecticide, it will show the Anopheles, both not both that all of primary vector of malaria, so can like a susceptible for all of like a chemical insecticide. So we have some possible area that we trend to be a possible resistance, but the whole country. But this is like a sentinel site we do in the Thailand. So normally in Thailand we okay with insecticide resistant. No, not susceptible, not resistant. This is like the table show the coverage of LLIN in Thailand 2018 to 2022. But 5 years we distribute the LLIN a lot, and percent show that we have around more than 93% in 2018, and also more than 100% in 2021. And this year because this is like in November, we have like only 75% coverage by LLIN. So this is like a 3 years coverage. For the population protect by indoor reservoir space by 5 years, we have like we have planted sprayer, household sprayer, and we do more than 98% in household coverage in 2018, and it still increased by the 5 years, and this year we have, so it's like we do a good job in IS from 2018 to 2022. Also for the entomological monitor, the LLINS that we distributed, we have test efficacy by doing bioassay tests 3 years from 2019 to 2020 under the II2E and II3E project. So we do in first year 2019 to 2020, we do in Connecticut province, we test the LLN which is delta metrin 45 milligram per square meters. The brand is permanent, and also we use the Anopheles minimus as a species to do a test. Also, the results show that if in the year 2 we have like a mortality more than 80%, that is confirmed that we can use the RNS in the efficacy is okay. So for 2021, so we have the COVID pandemic, so we didn't do this activity because due to many factors in the pandemic, COVID pandemic. So, but we do in this year. We try the different province. We do in the TAC province, and also we do at the same LLIN insecticide, which is delta metrin 35 milligram per square meters, and also the band is Yahi, and also we use the same species, which is Anopheles minimus, and also we in the first year of LLIN we have mortality more than 80%. This is due by division of vector-borne disease. For Thailand Malaria Online, in Thailand we have the surveillance system we call Malaria Online, with the purpose for surveillance the malaria situation and also the vector aspect. So we need to surveillance data to information and also reaction by doing something. So we focus in malaria not only the case, but we also have like a mapping of mosquito, as you see the previous slide. So we have the mapping, and also we have the intervention monitor, which is 137 strategy, and we have the data about vector control and also IDS. So we use the surveillance data from programmatic action. So in Malaria Online information, we perform outbreak detection in national level, and also we use Malaria Online for another purpose like planning, budget allocation, and also especially in intervention monitor and also area stratification. This is Malaria Online used in the programmatic action in national level, and also in the it's leveraged in also in regional level as well. By achieve the elimination, we have mobile technology for foresight management we call mHealth. mHealth is like the program that correct the data from many aspects like IRS data, monitor and evaluation, LLIN data, and also the data from Malaria Online as well to perform the management. The objective of health application is to use like a map to target the guides and help staff to deliver appropriate service, and also to monitor field intervention coverage and make adjustment, and also be implemented. Health is implemented in the as a routine and also foresight response. In 2019, DBBD implement a pilot project in 3 provinces, Tra, and also Ubon Ratchathani. So this is supported by the virtual and also more than participants in the list. The challenges in Thailand, the first one is limited training on malaria control and public health entomology from young entomologists and new staff. So we have a dynamic entomologist in the regional level. So sometimes some people didn't have like the well-trained entomologists. So we lack of training for the new entomologists. So this is like a challenge. For the solution, we will establish a working group to develop a specific course for like a new entomologist and new staff, and also be training course integrated with VCU workshop. And also the second challenge is also is a limited financing. So this is the way forward. The solution is increased funding support from like another governments or TF for local administrative organization, and also who are uses this solution from the second challenges. For the third challenges, the operational research relevant to the outdoor malaria transmission control. The majority in Thailand is the outdoor transmission, so we need to collaborate with the research institutes, including university and FIM, and also another research institute to try to combat with the outdoor malaria transmission control. The challenges number 4 is like out of the guideline of procedure from entomology and vector control. So to revise is the solution is to revise the SOP and guideline for the entomology and vector control for our regional staff, and also like Oracle administrative. So this is the solution from the number 4 and 5. The last challenges in Thailand, we lack of collaborative with network for the implementation of Sentinel site for vector surveillance and also review of public health insecticides. So by target with this challenge, we establish the National Insecticide Committee, and also we establish the vector surveillance committee to review public health insecticide policy, and also to decide the standard of insecticide and also vector surveillance in Thailand. This is our challenges in Thailand. So, and finally, by achieve Thailand malaria elimination, so we conduct Center of Excellence for Entomological for vector-borne disease, which is developed from 2022 to 2031. This is the plan. We aiming to protect our people by monitor, prevent, and control according to international standard for vector-borne disease. But not only do standalone, but cooperative with network partner and also our sector in years 2022. The aiming of this, we have 2 excellence center. The first one is Center of Excellence for Entomological Surveillance, and the second one is Center of Excellence for Sprayer and Insecticides. So we have a timeline by 2023 to 2032, and activity we for example we do SOP development, and we will achieve ISO this 17025, and also we will develop the vector control and surveillance system, and also we will improve our PCR and ELISA diagnosis, and also we do cooperate with the public health lab network. So we not only do training unit and also public health surveillance, and we will exhibit the vector control special service, and also we conduct different BBT lab, and also we do more research about vector control. This is the timeline for our Center of Excellence for Vector-borne disease. This is like my presentation. Thank you for listening.
Hello. I think Leo, you're on mute.
Yes, I've just unmuted. Thank you, Wu Lan. Thank you for that. Thank you, Dr. Pongsakorn Kopon Krap. wonderful presentation. You know, I've had some insight into the operations of your department, extremely professional, very high standard control operations that your department implements. Strong congratulations to the work that you are doing. But disturbing, the surge in case numbers this year compared to last year. There are reasons for that. But despite that, you're still aiming for 2023 for falciparum elimination. So things remain on track. But very well done. Congratulations to you and your department and colleagues. Thank you for your presentation, Dr. Pongsakorn. So I think what we should do now, the question and answer session is always a very popular and important session where people can clarify and get more detail that they would like to have responses to. But we need to take, say, a 3-minute break just for people to stretch their legs and go to the bathroom and so on. So why don't we break for 3 minutes? And then when we come back, then we'll have a question and answer session, and hopefully our presenters will still be available to respond to those questions. Thank you so much, everyone. See you in about 3 minutes.
Would you read the rest? Never mind.
Okay, hello everyone. Welcome back. So we're going a little beyond the time that we had anticipated, but it's important to have this Q&A session. Wonderful presentations. What a great set of presentations. I see Wulan has prepared some questions here. Thank you, Wulan, for extracting those questions and putting it in a question table over here. First one was by Dr. Susanta Ghosh. Hello, Dr. Ghosh. And the question is to Amir. What kind of attractants are used? Now, I don't know if that's intellectual property rights, but let's see how you respond to that one, Amir.
Okay, hello everybody, and thank you very much for, as you said, an extremely interesting presentations. The actual attractant, yes, it's not something that we are revealing. However, we can say that the main attraction and our formula, the main element of the formula is a fruit juice. It's a natural fruit juice. And more specifically, it's natural date juice. This is the main, I would say, substance in the formula. This is as close as I can say at this point. Thank you.
Thank you, Amir. Good response there. So here's another question by Arisa. So, I mean, the question here that you as well is has there been effect of this on beneficial organisms like toxorhynchites? I think you basically did respond to that one, Amir, in your presentation, that you know, the active components are sealed behind a membrane. So it's only really insects with a piercing proboscis and that respond to those particular stimuli that will probe and penetrate and access the toxic ingredients. So I think, do you want to add to that, Amir, or do you basically agree that most of the beneficial...
Of course, I agree. Thank you, Leo. However, we still tested it. We tested it in Mali during 2016 experiments the first time, and also during the entomological trials that started 2020. And we certain that there is no harm for NTOs, although most likely we should keep during the time in various locations, in various conditions. It's very important that we are not going to harm any organism.
No, I agree with you. You have to be super conscious of, I mean, insects play such an important role in multiple different ecological functions, pollination, decomposition, all kinds of aspects, and you interfere or you do damage to at your own peril. So we don't want to interfere with non-target organisms. And my concern, Amir, is not while the bait station is up on the wall and being monitored. It's after you discard that bait station, when it's being degraded, it becomes brittle, and the membrane, breaks in the garbage dump, and it's there that the active ingredient, due to sunlight, maybe the membrane becomes brittle, And if the active ingredient is still active, then it could be a problem for non-target organisms. So that's the one thing that keeps going through my mind.
Yes, you're absolutely right. I would say that oil disposal is a big issue that we are thinking about and have some ideas. However, at this point, out of the 400,000 and more stations within the test, the disposal, fully disposal with incineration, with a very high temperature incineration that basically leave nothing out of it. But we don't think this will be for a very large scale deployment, will be the right solution. So, as I said, we are seriously thinking about it and have some ideas, and we really hope that toward the commercialization, it will come also with a disposable method, proper disposable method.
Thank you, Amir. Point taken. So here's a question from my old colleague, Dr. Tin Cho Thu. Good to see you participating, Tin. Thank you. Tin is now at Global Fund in Geneva, and I see he directs the question at me. And he asks, it will be useful to know what are the national malaria programs as key operational or implementation research questions regarding these new tools like ATSBs to be introduced to their toolbox in the context of existing tools, etc. Could APMEN perhaps help in facilitating this? I mean, it's a very valid and interesting question, Tin, and I can only talk broadly in response to say that, my impression is national malaria control programs will only deploy tools that have been endorsed by WHO. So new tools that are still in development on trial, those are still research tools. So until they are deployed, they enjoy WHO PQ endorsement. There's probably no likelihood of mass deployment. The other comment I want to make, at least in the Asia context, is for some of them, like ATSBs, at least Greater Mekong subregion will probably have reached elimination before some of these tools receive PQ endorsement. So, but I agree with you. For example, ATSBs being a particular example where, as far as I'm aware, they're only being trialed in Africa. And it would be appropriate to do some equivalent trials maybe in Asia. And again, dengue comes to mind. Amir was describing its application not just for Anopheles, but also for Aedes mosquitoes. So it would be appropriate to replicate those trials under Asian conditions, and specifically to see social acceptance of these methodologies. So these are issues that one should be discussing with national programs. I quite agree with you, Tin, to test their level of interest and see where their focus might be. Thank you for raising that. Topgi poses a question to Amir. Excellent presentation. Such innovation is required to fight the last mile. Any possibilities in getting few products that we can try in our hotspots areas along the international border? So Topgi, I'm sure all the people involved in the discussions today could refer you to manufacturers or point of contact people. I suggest you make direct contact with those people and pose your question. So Aradana, Dr. Amir, thank you very much for informative presentation. does this attractant work for all Anopheles and Aedes species? I suspect you're going to say you targeted the disease vector species, those Anopheles species that transmit malaria, and then, you know, Aedes that are known arbovirus vectors and so on. But in the field trials, are you getting a broad response where I don't see why not, why other species of Anopheles, non-vector species, shouldn't make equal use of your bait stations? Do you want to comment briefly, Amir?
Yes. For the time being, we can see that, especially for Anopheles, all of them are attract. It might be with various, you know, and some may be a little bit more, which we cannot see. Those are related also to Aedes. They are attract, but we don't know if it's exactly as the Anopheles, maybe less. The whole development was done with Culex, so for sure Culex are extremely attractive to our bait. So for the time being, we couldn't find any mosquito species that is not attracted. However, I cannot say that all of them are attracted exactly at the same level. But this is something to prepare down the road in order to check exactly what type of attraction are more suitable, maybe for this species or another one. Thank you.
Yeah, thank you, Amir. And I'm assuming that the toxicity level of the active ingredient has also been determined according to the prime vector species that you have in mind. And then, you know, some of the other species may not be quite as susceptible, or maybe more susceptible. It depends on the species.
Yeah. The level, I would say that the toxicity is not an issue. I would say that the level, the very small amount that we put is more than enough to kill all type of Anopheles, and it's not an issue at all.
Okay.
Much and a very, very small meal will kill the Anopheles.
Okay, thank you so much, Amir. Tobgi again asks, I posed as a question to Victor. What is the potency and efficacy of dual spray chemicals on direct exposures to sunlight? In other words, is exposure to sunlight going to degrade the potency of the active ingredient being used? Victor, do you want to comment on that maybe?
Sure. So that's a good question, because pyrethroids are usually regarded as being degraded by the sunlight. In this study, we choose the lambda cyhalothrin, which is slightly more resistant to sunlight. So it's the first argument. And then when we spray inside the nonce bushes, maybe some of the compound is not directly exposed to sunlight. So these are two factors. It's degraded over time. We don't really know how, but what we could see from our experiments using cone tests, even if it's degraded, it can last for several weeks. So that's my answer to the question.
Yeah. Okay. Thank you, Victor. But you're not off the hook yet. Here's a question from Tom Burkott in Australia, who asks for bees. We heard from Amir that bees couldn't access the oral toxin, which is good. But for outdoor residual spraying, do you have any evidence or know of any evidence of the impact of this ORS on non-target organisms, for example, bees and other pollinators? Just your general, in your general knowledge from reading around the subject, have you come across studies that have measured or have some indication of the impact of the kinds of practices that you're using? Any comment, Victor?
Yes, we don't have data on that. That's a limitation from our study because it's really difficult to collect, obviously, and it requires to sample diversity of insects and to have the skills to identify them. In practice, we know that it has probably an important impact on non-target organisms. Regarding the pollinizer insects, we avoided the flowering plants and to spray near natural beehives. So it's mitigation measures that we implemented. I don't have knowledge. There might be of publication looking at the effect of outdoor use of insecticides on other insects that are not pests or vector. I don't have specific example in mind, but what we see on the border is that there is a huge use of insecticides for agriculture, especially. So there may be some parallel to do. We know that in the fields where there is a massive use of insecticides, that comes with a decrease in the biodiversity of the insects. So it's probable, but we try to mitigate. And something that is important as well is the size of the ecosystem is actually really small. When we go in Karen State, it's quite wide. There is a lot of forest, of village. We spray a few villages, so we don't expect to destroy all the biodiversity in Karen State, but locally there may be an impact.
Thank you, Victor. So here's a question from Tin Chothu again, and he says, great research on the outdoor residual spraying to reduce outdoor transmission. His first question is, did you study the residual protective effects from outdoor residual spraying? How long does it last? I think you did refer to that, Victor. Do you want to respond to that question first?
I'm not sure. So for the duration of the effect, we have data from the lab experiment with cone test that shows the efficacy on the vectors. From the cluster trial as well, we assess the effect at different time points from months 0 to 3, 3 to 6. So we could see that the effect on mosquitoes, the lethal effect can last during the rainy season for about a month or so, but the impact on mosquito population may be longer actually due to reduced longevity, reduced abundance. After another limitation of this study is that by looking at biting rates, we don't directly assess the exposure, the actual exposure, which will require salivary biomarkers, exposure to mosquito bites. And I think there is a presentation of Freya folks on the third days who may comment on that.
Thank you, Victor. So I don't quite understand the relevance of this question, but let me raise it. Question 2 is, are there mass drug administration activities still going on during the outdoor residual spraying period? As I say, I don't know what the link is there, but maybe I'm just not seeing it. Are you aware of NDA activities that were going on while you were doing that outdoor study?
Yes, there have been several studies published by our group on the use of MDA in our elimination program. It has had a very important role and contribution to the elimination. In this study, in this cluster trial in the 12 villages, there were no MDA activity because the MDA was implemented to eliminate drug resistance falciparum malaria. And as I explained, during this study, falciparum malaria was already gone from this area and from these villages. So we didn't implement MDA at the time of the study in these specific villages.
Thank you, Victor. Sorry. And then he asks, are there any difference in Vivax incidence when these additional interventions are layered in on top of L-Alliance and so on? So you've responded to the MDA issue, but what about this? Did you pick up differences in Vivax transmission?
Yes, so this study used the incidence of Vivax malaria as a secondary endpoint to have a more accurate estimation on the transmission of Vivax that will require a different design and a bigger sample size. We have both theoretic argument and our observation from the trial that when we prevent new infection with Plasmodium vivax, we prevent the primary attack, but also the subsequent relapses. And we think that from one natural mosquito bite, there is an average or a median of 5 sporozoites injected and 5 subsequent relapses. So the impact of vector control on Vivax malaria is on the incidence is expected to be much bigger than for falciparum malaria. But because the relapse occurs after the inoculation, there is a lag in this impact. So this is why in this study we looked at month 0 to 6 and then 6 to 12, because in the case of our local Vivax strains, most of the relapse are expected to occur in the 6 months or in the year after the inoculation.
Okay, thank you. Victor, I'm going to start jumping questions now because we're running out of time, but let's allow a few more. I was just wondering the effects of weather such as rain on the effectiveness of the outdoor residual spraying. Of course, the rain is going to wash off the insecticide. Do you want to comment on this briefly?
Yes. We have a few data, not a lot of data on many insecticides and type of bush, but in the experiment we did on bamboo bushes, when we spray during the rainy season with the same dose as the dry season, the duration of the effect is shorter, from more than 100 days in the dry season to 42 days during the rainy season. I'm speaking about the mortality in the cone test. So it's also a point to mention, but it shortened it, but still, at least with the capsule suspension of lambda cyhalothrin, the duration of this residual effect is long enough to affect successive generation of mosquitoes. After in the trial, we didn't looked at specifically the effect of rains because it would require a different design with many clusters during the rainy, dry season. Here we just did one round of spraying at the end of the rainy season. So yes, that's a good question.
Okay, thank you. And then a question also to you, Victor, from Dr. APMEN from Myanmar, who has vested interest, obviously, because the study took place in Myanmar, and she asks, which vector is the main vector in this particular area that you were working in, and its resistance status, presumably to pyrethroids that you were using?
So the diversity of the vector species was more or less the same as what we had from previous experience in this area. So a very huge diversity with many species groups and complex of cryptic species, maculatus, minimus, dirus, Barbirostris, Hyrcanus, Annularis, etc. In these specific studies, in the cluster trial, Annularis was quite predominant because they were flooding before. At the beginning of the rainy season, there were huge flooding during this year. So Anopheles annularis multiplied a lot at that time. We also had a lot of Anopheles hyrcanus, which is very zoophagic. So in the cobated trap, we had a lot of hyrcanus and maculatus. The resistance level are very variable according to the species group, to the species. With, for example, Hyrcanus, Barbirostris being highly resistant, and other species like Minimus, Dirus being not resistant or at very, very low levels.
Okay, thank you. Here's an interesting one. Mr. Pongsakon, here's a question from Topgi. You made the statement that there's a 187% increase, if I remember correctly, year on year from last year to this year. Can you speculate or give reasons why for this increase, dramatic increase year on year? Just your comments on that, please, Mr. Pongsakon.
Yes. For the reason that the malaria case in Thailand are increased, that we have the massive of movement between Thai Myanmar border. Yeah, so this lead to the increasing of the malaria case in Thailand. So majority they from the Myanmar, and also they have infected with malaria, and also this is why reason why the malaria case in Thailand are increased. Yeah, especially in the Tra province.
Okay, all right, okay. Yeah, all right, point taken. Thank you, Mr. Pongsakon. Yeah. Then Amir, question from Dr. Pradeep Srivastava from New Delhi. He's asking, what was the dosage of the main active ingredient in ATSB? I suspect that's intellectual property rights again. But more importantly, perhaps in a general sense, its residual efficacy, or how frequently do you have to replace the bait station? How long does this bait station last?
Can you hear me?
Yes, I can now. Thank you.
Okay, thank you. First, the bait station should last 6 months. It's tested for 6 months, no problem. Also, we try to make it longer, something like 7, 8 months, and it looks okay. But for the time being, the official one is 6 months. So this is about how long it will last. And the question disappeared.
The question disappeared.
Sorry, wait a minute.
Okay. The toxic, by the way, the toxic is dinotefuran by Mitsui. That's the current one that we are testing, and we expect to have at least 3 active ingredients in order to be able to rotate them in order to avoid resistance in the future. But for the time being, we are using dinotefuran by Mitsui. There is because of this, the quantity, the small quantity, there is no issue with the residual efficacy. At least we didn't find it, and I would say we totally incinerate the station. I think this is, and what is the effective area? Yeah, no, that's fine. I think that's the answer, that we do not see any issue at this point of residual efficacy because of the incineration. Okay.
Okay, thank you. Pradeep, you asked a fourth question here for Mr. Pongsakorn. How are you managing mHealth and online surveillance of standard operating procedures outdated? Yeah.
Sorry,
Pradeep,
it was instead of off, it is if because the statement was the SOPs are outdated. That was a challenge. And mHealth and surveillance is online. It's a new technology. That's what my question.
phrase your question again, Pradeep. I don't understand your question. Just ask it again, please.
My concern was that if our guidelines and SOPs are outdated, how the new technology for online surveillance and mHealth is being managed, because that was the challenge shown.
All right. Mr. Pongsakorn, do you want to respond to that question?
Yes, thank you for the question. So first, I will introduce as my presentation. The mHealth is a tool for correct data, for visualization, and also like analytic data, but also an online surveillance as well for malaria online platform. So the SOP are outdated. It's only the surveillance, the vector surveillance, not the case, not the protocol or other protocol, but only the vector surveillance and vector control we need to update. But during this period, we do follow the usual guidelines. So we try to update the new post from WHO. So we focus the major challenge only the update from update for vector surveillance and vector control, not case, because we have standard for case investigation for M&E, but not we had only update about the vector surveillance and vector control procedure.
Okay, thank you, Mr. Pongsakorn. I think we've kind of reached the end of the written questions in the chat box. So I'm going to ask one time before we move on to breakout group, a short session of breakout group. Please don't go. I promise you won't be long. But I'm going to give the opportunity if anybody wants to raise a hand and pose a verbal question, please go ahead. Just either raise your hand or just unmute yourself and ask if there are any more questions anyone would like to ask while we have this wonderful panel of experts available. Anybody with a question? Okay.
I do have a question. Sorry.
Victor, is that you?
Yes, it's me. Sorry, Victor speaking. I have a question as a researcher on these innovative tools, especially, for example, new insecticides or new devices such as the bait traps. But what is the regulatory framework in Thailand or elsewhere, or to supply? What is for example, if tomorrow we want to do a study on, for example, transflutrine, I'm not sure it's approved by FDA in Thailand, to do a study in Thailand with this product. What is, I don't know if someone wants to comment on that, or in another country, or has this kind of question in mind, the supply chain and regulatory framework to evaluate new things for research purpose.
Yeah, Victor, you touch on an extremely important and very frustrating question. There are a lot of people are very frustrated by that question. The time it takes to, get a new product approved, and then you have to do it in each and every country. Why can't we speed up the process? And if you prove it in country A, why do you have to repeat it in neighboring country B? Why can't the same experimental results be accepted for application in the approval process in country B, C, and D that are direct neighbors and have the same vectors, for example. So it's an extremely important question you ask. And I'd like to ask anybody, is there anybody willing to respond to this question by Victor? I think your question was specifically targeting Thailand, Victor, given that you're based at Shoklu and you probably have something in mind. Mr. Pongsakorn, do you have any thoughts around that? I know it's a very specialized field and maybe you don't have experience there, but if you do, it would be worth hearing your opinion. Mr. Pongsakorn?
So can I have a question again?
So the question, Victor, you let me not, you ask the question again.
Sure. My question was not relating to any personal interest, but in the last years, I was doing some research on vector control. I faced the issues that, okay, there may be a new intervention promising or new compound, but then the problem is to procure the compound and to find the legal framework to evaluate it. For my experience in Thailand, it may be elsewhere. But for example, if I take transflutrine, most of the studies I see are conducted in Indonesia. I wonder if, for example, is it easy to procure transflutrine tomorrow in Thailand or in Laos or in Myanmar to conduct additional research? It's an example. It can be for another compound or product.
Okay, I see. So you ask about the procurement, about the new innovative tool. So in my opinion, so all of insecticides and surveillance, all of insecticide should be registered by FDA, and also the new innovative by approved by operational research to use in Thailand. So by the way, if you need to bring the new innovative to Thailand, so need to talk with the division that take responsibility to do that. If you need, for example, if you have a new trap, so you go to Thailand, and so you talk with our division, and also we can conduct operational research and issue some paper, and also to public, and also we like to use it. We can lead to policy, but not to the whole country. So it's like paper. Except if you have a new insecticide, you need to register by the FDA, Food and Drug Administration in Thailand, and also any use of insecticide and chemical in Thailand, we have the Thailand Procurement Act. So you need to notify the FDA, which is responsible for the insecticides and also like a toxic material, something like that. Is it like your question?
Yes, sure. It fully answered. Thank you very much.
Okay, thank you, Mr. Pongsakorn, and thank you, Victor. Yeah, it sounds like you need to contact the relevant departments or divisions directly and make inquiries. And you would have to do so in each particular country that one would want to work in. So thank you so much, our audience members, for that stimulating range of questions. I want to ask, if I may have 15 more minutes of your time, where we break out into 2 working groups to respond to an 11-question questionnaire that is very simple and very straightforward. It's tick boxes, very simple questions that relate mainly to the use of outdoor outdoor biting reduction tools. So what we'll do is many of you will already have been pre-assigned to particular groups. The one group will be South Asia and East Asia, and the second group is going to be kind of Malay Archipelago, Pacific Islands, and so on. Some of you who we weren't sure would be attending or not, are not pre-assigned. So you will have a choice which group you want to join, depending on your personal interest. So there are two groups. There's going to be a little pop-up box that appears at the bottom of the screen, and you can just click on the South Asia, East Asia group, or click on group 2, which is the Malay Archipelago, Pacific Islands group. We'll give a couple of minutes so people can then be moved to those two groups. Once you're in those two groups, the facilitator of that group will put on screen a QR code and a URL, a link that will enable you to open up a Microsoft form that has all the questions. And it's going to take you, once you start with it, it'll take you 3-4 minutes probably, that's all. So, and then we can come back to plenary session and give a summary overview of what the responses were. So sincere thanks to all. It's not going to be a hardship assignment. So Wulan, Dr. Porn, how do people choose where they want to go?
Dr. Leo, I open the breakout room so they can choose which groups they want to go. It's also pre-assigned, so NMCP people from those groups are automatically assigned to that respective group.
Thank you, Dr. Porn. The box I see it says close all rooms or broadcast. I don't see.
Just click join button.
There's no
it will
join
say-
button. There's no join button.
You have to scroll the pop-up window until you find.
Okay, yeah.
It's
So
Asia menus. Yeah.
on the gray bar at the right-hand side, just scroll down and you'll see South Asia and East Asia. And you can click join if you want to join that group.
Yeah.
Or if you scroll down further, you'll see Pacific Islands and Southeast Asia. So just scroll down and whichever group you would like to join, just click on that group and you'll be bumped into a separate meeting room.